I'm off to the Institute of Sound and Vibration Research in Southampton to find out just how powerful sound can be. I'm meeting Professor Fahy, who's experimenting with some pieces of paper. Wow! Was that the sound that was causing the paper to move like that?
Yes, it was, but I had to make a very loud sound to make it happen.
But what actually makes sounds loud?
Well, you know that sound is caused by things that vibrate, and the bigger the vibration, the louder the sound.
When I hit this drum gently, the vibration is very small. The polystyrene balls only just move, and the sound is quiet. The loudness of a sound depends on the size of the vibrations that made it. The size of a vibration is called its amplitude. The bigger the amplitude, the louder the sound. So sound can move pieces of paper, but let's put sound to the test and see what it can do to this. I've built my tower on a toughened glass sheet, and underneath is a speaker through which the professor is playing a sound. How are we able to knock down my tower without using the big, powerful vibrations of a large amplitude sound?
Well, Femi, that's because there's something else involved, and that something is called frequency.
When you tap this glass, it makes a sound as it vibrates. This piece of equipment counts how many times a second the glass is vibrating. The rate at which something vibrates is called its frequency. Frequency is measured in hertz. This glass is vibrating 400 times a second, so the sound has a frequency of 400 hertz. This sound has a frequency of 200 hertz, and at that frequency the sound makes the sheet of glass vibrate so much that the tower topples. Okay, so sound can move paper and it can cause enough vibration to make a tower topple, but what could it do to a wine glass? Could we break it?
Well, I don't think so. We've never managed to do it before. But if we use the right combination of frequency and amplitude, we might see something interesting.
So if we used a sound that's a very large sound with a very large amplitude and a frequency, that's the same as the glass.
That's right. Let's experiment.
This experiment's conducted in a specially soundproof room to stop us being deafened by the very loud sound we're going to use, which is louder than Concorde at takeoff. A strobe light helps us see more clearly what's happening. And look. The sound is making the stiff glass behave like jelly. Impressive.